Hey Algebra 1, here are your notes for 12.6 rational expressions with like denominators. So to add or subtract rational expressions with like denominators, we just add or subtract the numerators and put the sum or difference over the common denominator. Hey, guess what? Rational expressions work the same way as fractions. So, like I talked about in my last video, let's do a little example over here. If I have 1 over 4 plus 2 over 4, it is the same thing as saying 1 plus 2 over 4. 1/4 of a pie plus 2/4 of a pie is equal to adding the pieces of that pie together and saying I have 3/4 of a pie. Now it might not be the same pie, but anyway, I digress. So we also want to simplify the resulting rational expression if we can do it. That's when I say simplify as far as possible. Let's make sure we do that. Anyway, notice, first things first, can I add it because they have like denominators? Absolutely. So what I'm going to do, and I'm going to show you the step for this first one, but I won't from now on just for time's sake. 5n over 15 plus 7n over 15 is the same as 5n plus 7n over 15. Same. Add. Everything lines up. All right, and then let's simplify that. 5 and 7 is 12. Notice I'm adding their coefficients, not their variables. 5 apples plus 7 apples is 12 apples. Okay, let's remember how we add things. And then it's over 15. Here's where it comes in to simplify 12n over 15. I can't simplify the n, but 12 over 15 does reduce. So if I reduce that fraction, both are divisible by 3, it's the same thing as 4/5. 12 over 15, same thing as 4 over 5. So I want to simplify and make sure my answer is reduced. All right, let's check out another one. 3x over x plus 2 plus 6 divided by x plus 2. Same denominators, let's add them. 3x plus 6 on top over x plus 2 on bottom. Now, looking at this, you might not see any way to simplify. However, my suggestion to you is when you get something like this, see if there's any way to rewrite the top or the bottom in order to determine if there's something that can cancel. So for example, when I look at this top part, I go, well, 3 and 6 are both divisible by 3. So if I factor out a GCF, a greatest common factor of 3, I'm left with 3 times x plus 2. Now I know from my previous videos that you know when things are multiplied and you have something that is the exact same on the top and the bottom, that those reduce to a big fancy 1. So 3 times 1 divided by 1 is the same thing as just 3. And this is why we want to reduce if possible. Because if we take something like this and we turn it into this, yeah, that looks nice. But you know what looks even nicer? Just a single number. So always do as much work as you can so that your answer looks as nice as possible. Don't leave me at this step. Don't get lazy on me. All right. Next one, same denominator. However, I have to pay attention to this subtraction sign. This subtraction sign is going to go to all the terms on the top. I'm subtracting the entire thing from the entire first piece. So in this case, I am going to rewrite that top. 3x plus 2 minus 4x. If I had a second term here, I would also have to distribute that minus into the second term. In this case, I don't have to, though. Over x minus 2. Let's just simplify that. 3x minus 4x is negative x plus 2 over x minus 2. All right, that looks pretty good, except those look really close, and it'd be really nice if there was a way for me to simplify it. In fact, it'd be really nice if this had an addition sign in front of it and that had a subtraction sign in front of it. I wonder if there's a way to change both of those signs. Well, let's try this. Let's factor out a GCF of -1. If I do that, I get -1 times x minus 2 divided by x minus 2. Hey, that worked. And it allows me to reduce x minus 2 over x minus 2 to just 1. -1 divided by 1 is -1. Hey, that was a pretty convenient problem. Let's keep going with this. Try the next 3 on your own. Pause the video now, try those. If you're really feeling confident, go ahead and do all 6. But whenever you're ready, come on back and we'll go through the rest of these together. All right, hopefully gave yourself a chance to try those. Hopefully you were also careful with the subtraction problems. I know they can be a little tricky. So let's go through these. First one, x plus 3 divided by 6 plus x minus 2 divided by 6. I'm adding everything on the top, so that's x plus 3 plus x minus 2. I'm going to add like terms. So an x plus an x, an apple plus an apple is 2 apples, or 2x. A 3 plus a -2 is a +1. And it's all divided by 6. You know, I look at this one, they're not all divisible by anything. There's no greatest common factor that I can factor out. So this one is done. I'm just going to let a check mark by it instead of boxing it. Next one, I noticed they have the same denominator. We're good to go. Again, let's add like terms. M plus 3m is 4m. +1 plus -3 is -2 over 2m minus 1. Can I simplify that? Well, I noticed the top two have a 2 in common, so I could try to rewrite it as 2 outside of 2m minus 1. I'm really glad that I tried that, even if it hadn't worked. Fortunately, it did work, because now I see that it has a 2m minus 1 on top and on bottom, which when I reduce, gives me an answer of 2. I like that. Let's keep going. Another addition problem, both over x minus 4, so I don't have to worry about the denominator yet. In fact, I'll tell you, because this is the rational expressions with like denominators, I won't have to check on this entire worksheet, but I will have to check on the next one, because we start with non-like denominators. That's going to be fun. Anyway, like terms on the top as well. -8x plus 4x is -4x. There's nothing to add with the x squared. It's all over x minus 4. This one's really tricky because these don't look like they have anything in common. But if you notice, the top kind of does. If I factor an x out of both of those, I'm left with -4 plus x over x minus 4. And we're going to talk about this a little bit more on the back side of this sheet. But what you'll notice, if I turn these two around, I put the positive x out in front and the -4 out in back, that's the exact same as x minus 4, which then cancels and leaves me with just x as my answer. And like I said, we'll talk about that more in a minute, but there's a little preview. All right, the subtraction problems. These ones can be a little tricky. In this case, we can still do just 7m minus 4m to be 3m. There's nothing to combine with the 1, so plus 1 over 3m plus 1. Hey, guess what? When you have something divided by itself, your final answer is just 1. That's all there is. The next one is one that I want you to be very careful of, and this is the one that I was kind of warning you about. So this one I am going to do in the extended format. If I write this down, I have everything in the first fraction minus everything in the second fraction. And if I didn't put this in parentheses, it would sure look like I was just doing 5a plus 2 minus 4a plus 2. with just that minus sign being the 4a. But now that I've written it out, what I truly see is that I have to give that negative to both of these terms in order to do the problem properly. Rewritten, this is the same thing as 5a plus 2 minus 4a, and when I give it to the second one, minus 2 all over a squared. If I hadn't done this, that 2 would have stayed positive and I would have gotten the problem wrong. I have to be careful of that negative. All right, now let's combine like terms now that we've dealt with that tricky negative sign. 5a minus 4a is just a. Positive 2 minus 2 is 0. So I'm left with a over a squared. And like I've seen in other videos, this simplifies. This a gets canceled, it just becomes 1. And I'm left with 1a on the bottom. So my final answer is 1 over a. I encourage you to take a side note and see if you had not distributed that negative that you would get a different answer. Might be a good little side problem for you. All right, last one here on this page. This one, the negative only has to distribute to 1 since they're over the same thing. It's a minus 1 over a squared minus 1. You remember my cloud of death in one of the first videos. I said just because something is similar does not mean we can cancel. Meaning that negative 1 does not cancel with that negative 1. These are small ideas that are held together by parentheses. We can't just tear them apart. We can't just cancel things we want to. We can only reduce and cancel when there's multiplication involved. Now that being said, I can't change the way the top one looks. But after I look at the bottom one for a minute, I notice this is a difference of squares. And what I can do is rewrite it as a minus 1 times a plus 1. Now that I have multiplication involved instead of simple addition and subtraction, now I've got something that's the exact same. These were slightly different, but these sets of parentheses are perfect for cross-reducing. That leaves me with a 1 on top and a 1 on bottom. And when I rewrite this, it's 1 over a plus 1. If you had just canceled the negative 1s and possibly the a's, you would not have come up with this answer. So please be very careful when you're doing these problems, especially with a subtraction sign in the middle. I know I'm being repetitive. I just want you to not make those silly mistakes. All right, one thing to look out for before we finish up here. Sometimes denominators don't appear to be the same, but through a quick algebraic move, we can make them look the same. And this is what I mean. So, are x minus 3 and 3 minus x the same? Why or why not? Well, let's just test it with a number. If I say that x is equal to 2, that is the same thing as 2 minus 3. That would be negative 1. And 3 minus 2, which would be positive 1. Are those two things the same? No, they're not. That doesn't work. So these are not the same. And I'll show you even further why. If we give everyone a symbol, positive x, negative 3, and we give everyone a symbol here, positive 3, negative x. If I rewrite this one with the x in front to try and match this one, what I'm going to get is negative x plus 3, which is not the same as positive x minus 3. So by moving these around and rotating, they're not the same. They're not equivalent. But let's look at the next one and use the same method. Are a plus 1 and 1 plus a the same? Let's use our test. If a equals 2, and I'm just using 2 as a random number, I could use 34 if I wanted. It wouldn't matter. It's the same as saying 2 plus 1, that's 3, or 1 plus 2, that's 3. Now those do work. What's the difference? Well, let's give everyone a sign again. Positive a, positive 1, positive 1, positive a. If I switch these two around to match this, where the a is in front, I get positive a, positive 1. Hence, this is the same as this. We have to be careful when there's a negative involved. I know I said it a ton on the last page, but I'm going to say it a ton on this one too. Negatives are tricky, and we have to be careful. So, armed with this information, let's try a few of these together. Specifically, I'm going to try this first one. Are a plus 2 and 2 plus a the same? Well, if I give everyone a symbol, or I try my tricks that I had up here, is positive a plus 2 the same as positive a, positive 2? Those are the same, so the denominators are the same, which means we can just add the top. 4 plus 3 is 7 over a plus 2. It could be the same as 7 over 2 plus a. It wouldn't change it. Let's check out the next one, though. I now have a minus 2 and 2 minus a. Well, let's switch these around. Is positive a minus 2 the same thing as negative a positive 2? No, those are not the same. That does not work. So I cannot actually add or subtract those without changing the order of them. Same thing with this next one. You're going to find the same thing. But here's the trick. The same way that I can factor out a negative in order to multiply things or to cancel things, I can do that here as well. If I factor a negative 1 out of my a and my 2, I can say that positive a minus 2 and positive a minus 2 are the same. The question is, what happens with this negative 1? Well, I can either give it to the top and make it a negative 3, or I can change the sign and make it a negative in the middle. So I know I did a ton in this little area. Let's rewrite that. By factoring out this negative 1, what I turned the problem into was 4 over a minus 2 minus 3 over a minus 2. Essentially, I took that negative where it was causing a problem and I put it somewhere that it wasn't. That's all I did. Now that I have the same denominator, I can simplify. 4 minus 3 is 1. They have the same bottom. So 1 over a minus 2. Yeah, it's that easy. Let's see it again. 4 minus 3, if those two were the same, it'd be really nice. Well, let's factor out a negative from this bottom piece. Let's take this and change it to be negative outside of a minus 2. Just change the signs. I personally am going to take that negative, multiply it by whatever is there. If it's a negative, it becomes positive. If it's a positive, it becomes negative. And the whole problem becomes 4 over a minus 2 plus 3 over a minus 2. 4 plus 3 is 7, and this problem is 7 divided by a minus 2. There is your quick and easy algebraic move. It simplifies that whole problem a lot. So, that's all there is to it. Go practice. Let me know if you have any questions, and as always, watch your negatives.